With the growing demand for food and natural resources, along with rising global temperatures, more and more of the once fertile soils are degrading, turning arid lands into deserts on an unprecedented scale, bringing the livelihood of millions of people at risk. But what if we could bring back life to the places where almost no life can exist? Will we be able to stop sand from swallowing our planet? Deserts usually form in the subtropics. However, scientists have observed that tropical latitudes are moving polewards at a speed of 30 miles per decade, and the deserts within are expanding. Analysis of rainfall data from the Sahara, the world's largest desert, shows that it now covers 10% more land since records began in the 1920s. But it didn't always look like that. 6,000 years ago, the Sahara Desert was a green grassland covered with vegetation. A slight wobble in the tilt of Earth's orbital axis turned it into a sandy area where almost nothing can grow. In that case, we speak of a process of natural desertification, which is in contrast to what is happening currently. Large areas of the planet are being desertified, reaching up to 35 times the historical rate as a result of human activity and changing climate cycles that affect the rainfall. Humans are driving the transformation of drylands into deserts on an unprecedented scale around the world, with serious consequences. The main drivers of land degradation are the expansion and intensive use of agricultural lands, poor irrigation practices, deforestation, urbanization, mining, and overgrazing. These unsustainable land uses place enormous pressure on the land by altering its soil. Eventually, all of this contributes to soil erosion, an inability for the land to retain water or regrow plants, due to a lack of nutrients or soil salinization. The regions of Uzbekistan and Kazakhstan surrounding the Aral Sea are a prime example of this, where an excessive use of water for agricultural irrigation was the main reason for the shrinking of the sea, leaving behind a saline desert. A rise in global temperatures is likely to accelerate the process of desertification, as evaporation rates increase the risk of drought. The Mediterranean region would experience a drastic transformation with a warming of 2 degrees Celsius. According to one study, with all of southern Spain becoming desert, another recent study found that the same level of warming will result in drying out of up to 30% of Earth's land surface. The risk of desertification is widespread and spans more than 100 countries, hitting some of the poorest and most vulnerable populations the hardest, since subsistence farming is common across many of the affected regions. About 2 billion people live on the drylands that are vulnerable to desertification, which could displace an estimated 50 million people by 2030. More than 75% of Earth's land area is already degraded, and more than 90% could become degraded by 2050. A total area half the size of the European Union is degraded annually, with Africa and Asia being the most affected. Libya, which used to be mostly non-desert in 1920, is now nearly completely covered by sand, having experienced a 500-kilometer advance of the Sahara during the dry season. But there are solutions and ongoing projects to prevent the sand masses from spreading, like regreening the desert. The roots of the trees will hold the soil together, reduce erosion from wind and rain, and help the water to infiltrate into the soil. They also help to retain the upper fertile layer during intense rainfall, making it agriculturally usable again. In addition, plants can cool off the soil and stimulate the water cycle by evaporating water out of their pores, which could increase the humidity and then boost the regularity of rainfall. The Green Wall of China is a successful example of that method. This plan was proposed in the late 1970s and has developed into a major ecological engineering project, where nearly 66 billion trees have been planted, and it's not predicted to end until the year 2055. It has decreased desert land in China by an annual average of nearly 2,000 square kilometers, and the frequency of sandstorms nationwide have fallen by 20%. Similar efforts have been made by the African Union in 2007. This wall spans over the entire width of the continent, which is up to 8,000 kilometers, and has $8 billion in support of the project. They have restored 36 million hectares of land and plan to restore a total of 100 billion hectares by 2030. It also created many job opportunities, with over 20,000 jobs created in Nigeria alone. Enriching the soil and restoration of its fertility is also really important. It can be achieved by reducing the number of grazing animals and growing crops which can extract nitrogen from the air and fix it in the soil instead. Succulents, dates, and food crops as grains, barley or beans are the most important. The animal manure can then be used to fertilize the crops. Yet, one of the biggest and most important points in those regions will always be the management of water. Rock terraces and small dams are used to harvest rainwater in Saudi Arabia's Al-Baida project, a technique that has existed for hundreds of years and was used by the likes of the Inca. These support afforestation of drought-resistant trees, such as date palms. They also focus on slowing down flash floods in the highlands, and over time, converting them into seasonal streams of wadis. In long term, Al-Baida hopes to transform the region into a savanna ecosystem. There are also a bit more crazy sounding ideas to regreen the desert, such as a massive solar farm installation that could create more humid weather conditions and therefore a greener Sahara desert. A model revealed that if the farm would cover 20% of the total area of the Sahara, the heat emitted by the darker solar panels would create a steep temperature difference between the land and the surrounding oceans, which would lower surface air pressure and cause moist air to rise and condense into raindrops. With more rainfall, plants will grow that reflect less of the sun's energy and evaporate more water, turning one of the most hostile environments on Earth into a habitable oasis. As good as this idea might sound, the consequences of a warmer, greener Sahara would be felt around the world. From drought in the Amazon to sea loss in the Arctic, it would raise local temperatures by 1.5 degrees Celsius and the world's average temperature by 0.16 degrees Celsius. The global temperature shift is not uniform though. The polar regions would warm more than the tropics, increasing sea ice loss in the Arctic. This could further accelerate warming, as melting sea ice exposes dark water, which absorbs much more solar energy. It would also reorganize global air and ocean circulation, which would cause droughts for the Amazon region. Basically, the same amount of additional rainfall over the Sahara would be lost from the Amazon. However, scientists believe that even simple and inexpensive interventions can have regional impacts, because the number of farmers in the high-risk regions is so large. More than 80% of the world's farms, mainly in Africa and Asia, are run by single households. Smallholders are now seen more as part of the solution rather than the main problem to land degradation. So, desertification is reversible. We can restore the degraded lands, but it's not cheap and requires a lot of effort, which means we'll probably never be able to restore all of them. But by curbing global warming and deforestation, especially in regions where soils are endangered, we might be able to save our planet from turning into a massive wasteland where almost nothing can survive.